let's begin with our next presentation, which is Ljuba and Alex from Bollinger+Grohmann. Ljuba is the head of design technology, and Alex is a trained structural engineer, also head of design technology. They are both responsible for shaping the digital strategy of BG in Frankfurt. And with no further ado, I'm going to bring them on stage.
Hello.
So, hello everyone. Okay, then we start directly. So our topic for today, and we already had a few nice sessions in the morning, for example, by Cristobal from your Studio. We are continuing now with the topic digital design communication. And just a short introduction to Bollinger+Grohmann. We are an office of around 400 people, distributed all over the world, mostly in Europe. And we are a mixture of architects, engineers, and structural drafters. And like what you see here, mostly Europe-based, but we also are Melbourne, for example, or Shanghai. And our core fields are structural engineering, facade, and with facade comes building physics, comes also fire engineering. And we also specialized in those aspects here, mostly about digital tools, because this is kind of one of the core things of Bollinger+Grohmann, like this technology-assisted approach. Also like fields which came new were this special foundation topics. And of course, we are forced to more and more also cope with refurbishment projects.
Yes, and we are engineers driven by passion for high-quality architecture, efficiency, and efficient and sustainable solutions and technical innovation. We at Bollinger+Grohmann are always keen about technical innovations and their implementation design process. So we're going to go through some build projects to show you our workflows and some milestones, tools, just in a nutshell. This is our first digital collaboration project back then in '99, the BMW bubble from Bernd Franken Architects. So Klaus Bollinger and Manfred Grohmann established the mindset that design is a collaborative approach and process between all the design parties. And this mindset was also implemented in this workflow for this project, from the idea to the manufacturing, which was digital one. And the result is quite awesome. This workflow we developed further thanks to Grasshopper in a complete parametrical environment. In this example of ESO Supernova project by Bernhard Partner, we had the luck that the architects build up a fully parametrical model of the whole design, and we were able to couple with it and linked our tools and our internal workflows directly to cope with it. At the end, not only the 3D geometry, but also the 2D workshop drawings were delivered directly from the model.
And maybe I add something to that. So this is, in a positive sense, total madness to script the whole building, change a parameter, and the whole sphere changes here, for example. But what was also nice was that our guys from Vienna exchanged with the architects with snippets. So like, here's a balustrade. Do you like this NURB surface, or should we change it a bit? And they sent around Rhino files directly. And with Speckle, for example, it would have been more fluent, but this is actually the kind of way how we like to collaborate with other design parties.
Yeah, and it's some time ago, the project, as you can see, started in 2013. This is how it looks at the construction site. So this is our second blob, basically, and our first Rhino project, by the way, the Kunsthaus Graz by Peter Cook and California. It was the iterative process of optimizing the outer skin shape and generating the structure accordingly, into taking into account also all the material specifications. And this kind of approach of
Sorry for the echo. Mic changed.
Okay. Good. Then are we still in?
Yes.
Okay, this iterative process between the skin optimization and the adaptation of the structure was not connected quite good back then, of course, in year 2000. But nowadays, with Grasshopper, thanks to Grasshopper, and the whole, we can build the whole parametric model just based on this one guiding surface, and deliver details in really high grade of degree, as you can see here for a workshop 3D model. Unfortunately, no photo of it, since it's not a top secret project. We did the same exercise with the diagonals for the European Zetro Bank by Koch-Himmelblau here in Frankfurt back in 2005. The main difference and the major difference is compared to the Kunsthaus Graz is that not only that this structure is visible, but is also a really important part of the design itself. And looks amazing. And nowadays, we have implemented this kind of iterative digital process actually on a daily basis for small scale projects, thanks to our tools like Rampa 3D from Clemens Preisinger and Octopus from Robert Fellinger, that we are able to have them completely in one digital environment.
And in the end, it looks easy. Like
yeah, it looks easy, but at the end, since it's one continuous column, as soon as one small part change, the whole structure needs to react at this change and be integrated. So it makes sense to have an optimization algorithm in it.
So, but now let's go to this topic of what we're actually talking about today. So it's SpeckleCon. We just want to briefly introduce the project, which is part of this SpeckleCon talk. It's the Elb Tower in Hamburg. It's a nice high-rise, one of the biggest ones in Germany, designed by Chipperfield. And the structure was done by our friends in Stuttgart, WHP. And we are responsible for the facade engineering. So it's a mixed, mostly mixed use without residential space. But this is a project which is also currently, due to economic situation, a bit on hold. But nevertheless, we are taking it here as a starting point for the SpeckleCon, because it's actually a nice parametric project with design communication. Brief introduction, like how we did it before, in order for you to understand what it's actually about. So, like what I said, we were responsible for the facade engineering. It was also by our colleague Osama, who's sitting here in the room. Basically, our first big facade BIM project. So it's like going big with the first run is quite impressive, and Ljuba supported with parametric concepts. And like with all those crazy shape projects, usually it starts with geometry in Rhino. Grasshopper, it's nothing which is done in the BIM environment. And then, of course, the BIM model and the documentation aspects. We have this hyperbolic shapes, which basically generate this facade. This is done by Chipperfield. And then basically, this is the envelope. And from there, we have this sky or catwalk, basically for the facade cleaning. And then basically jumping back, it's the actual facade building envelope. And this basically creates here in this GIF the facade face. And then from there, basically the whole thing. So you see it here. We have to do this shape. We have a curve. But also in order to be built, we need to rationalize it and create a polyline for that. So in order to basically also have more rationalized shapes and less elements, we need to basically have the intersection between the finishing grids and the facade curve, and then we have the polyline, but to have some kind of steps so that it more, or basically it's less elements.
The challenge in this geometry is like it looks like a vertical rectangular facade element, but in the end, due to this offsets back and forth, the transition on the horizontal level, so on facade detail level, is the challenging one, since when you cut the curved geometry with the fitting grid, you get completely different pieces per level.
So this is basically the overview, rationalizing the elements so that they are less unique. This is what we want to have, or more unique elements. Yes. So basically, we have then the shape. We create the inside Revit, or someone basically classified those panels where it makes sense. This basically assigned those elements that are the right family. And like family planning, usually in Revit, you need to prepare something, and then you have the whole bunch, and then you assign it. And you see already this is a very high detail, everything adaptive. So it's a good job by a colleague Osama here. Super impressive for the first project like this, and also a nice thing to show today here. And now over to Ljuba for how we would have done it today with Speckle.
Yeah, I spent some time to try out the process one more time a few years later with Speckle, and to see which parts would have been done much easier with it, and where are the points where is the profit basically for our workflow at the end. So we still have the same input geometry by the architects with the base polylines. The point is that, or the main difference will be, I can upload them then directly into my, via Grasshopper, into my Rhino, or in this case, into Grasshopper, compared to, the first workflow was done by Dynamo. This was also my first Dynamo project. It was kind of tricky to transfer the Grasshopper logic into Dynamo logic, and also deal with geometry in Dynamo, and it was super heavy. With Rhino Insight later, it would have been also not much more, it was a bit easier, but since it's Rhino Insight Revit, and the central file was huge file, it was really, really hard and slow to do all the geometrical analysis at the end.
But also to add to the technical aspects, like this in a collaboration, for example, Chipperfield could have sent us these curves. Basically, we could have created a pipeline which we then follow up. So every time things are changing, especially in the early phases, we could have had an automatic decentralized workflow, which is usually not possible in that easy way.
Yeah, so for you some kind of a small recipe on how to rebuild this workflow with Speckle. You can either receive the whole model or receive just a small part of it. In this case, I just needed the polylines, or we just needed the polylines. So just by pressing a button, you could receive the curves directly into Grasshopper. For the facade element generation, you need also the grid lines, since they are crucial for the subdividing. The step is a repetitive one, so it's the same actually like before everything in Grasshopper, just to sort the curve by level, to give them, to assign the orientation, the offset, and at the end, this kind of information was necessary for the input of the unique ID, which was assigned to the curtain wall surfaces, which were generated automatically. Of course, as Alex said, we need to do some, or we wanted to do some rationalization steps. So for the first transfer as a curtain wall to the Revit model, we just group the elements by their width and height. And with the boundary curves, it was it was an easy way of sending them to Speckle. Yeah, okay. This is how it looks like when you upload them into Revit. Since it was a curtain, it was done with adaptive families. So the curtain walls, which was imported, generated automatically. It was generated automatically a facade element, which was adaptive by the width and height and so on. And for since it was a nested family, there was a second step we add on to implement the special parameters, as we mentioned before, for the horizontal transitions. And this was done just with a Speckle parameter updater. We have loaded the geometry back from Revit and sent just the updates in order to adjust the geometry. It looks like an additional step, but this is due to the nested family issue, that these parameters for the final facade element geometry are into the facade element family. And but it's actually just one step, since after this the BIM people are able to adjust all the facade types and requirements just by changing the family into Revit and without interrupting the planning process.
And the process is the same for Dynamo. It's the same for Rhino Insight. So and also you need always the human in between who basically provides the information as well. So in the end, it is something like this. And we have here, for example, the acoustic components, and then we have the coloring, and then we have the whole model. In this case, in a lower detail. But now with the new Speckle connector options, you also are allowed to upload different detail levels. And think about that this is only the process itself, but we are communicating with all this stuff. So we can also rethink with all this digital stuff, like new ways. Like, for example, if you are the contractor and you as designer can provide the contractor a more granular overview of how complicated is this project for me? Should I consider this in the costs and so on? So here, for example, you can see like in a lower detail, the overview of the building, and the distribution of the elements, and here a unique element and the shape, and then you see, okay, how did those many types I have in a project, And then I can just click around a bit and get a feeling for this project and change, for example, something here in the type. And then I have basically those at the top at the technical central here of this building. So this is a nice thing. How you would do that is basically Power BI, and this is a strong suit of Speckle. Then you just connect those to queries. You see here basically a recipe, and then you connect basically both those queries, so to speak, in Power BI and say couple it by type. You can also couple it in any other way, but this is the fastest way. And this is super impressive, this stuff, what Speckle did. Here is also, if you haven't seen that, lots of nice tutorials, and also learned quite a bit of Power BI with that. So Speckle is not just a starter, but an educator. And in the end, you will have a nice building facade, and actually also nice building. And it would have improved our process back in the days. And not just in a technical way, but also the communication. So as we said, we have this interaction, the close interaction with the architects, which we really like as structure engineers, because we assist them in making a better structure, better building. And this is like project-based their introduction, but also internally we see it as a big benefit for us and have a big vision, because like with any engineering firm, there are lots of tools, and the more disciplines you have, the more tools you get. So this is super mad. Lots of tools which are mostly not connected, and I believe every engineering firm has the same nightmares. And you have like manual processes, you have everything connected, and our biggest wish is that you do it only once, but the reality is like design is interactive and it changes a lot, and we have to make it as easy and painless as possible. So if we have a project like the Elb Tower, we have our specialists like Ljuba or Sama in the projects, and this basically works like a breeze to get these projects like this. But also, we all know we have only like 10% in our firms which are on that level. And
also the projects.
Yeah, and also the projects that we have this budget. And when we have the regular projects, this is mostly disconnected, which is fine too. This is not as bad or good. But if we could have something in between, which makes it possible for everyone to work in a connected way, this would be great. And it doesn't need to be fully connected like this. But if there's something in between which makes it easier to communicate internally and externally, it would be great. And below there's this hint, in case someone from Ljuba is watching, it would be nice to have a connector from you as well. We are currently implementing Speckle at Bollinger+Grohmann, basically on a use case-based approach. So we have now a Speckle server running in-house, and this we need to basically improve a bit, strengthen a bit, so that it's able to cope with the 400 people. And then we are basically developing like simple tools, like for example, this parameter app.
Small building blocks, which we can just link our existing workflows in.
So the idea is basically like we have, for example, maybe go back one step. We have maybe building physics projects which have a BIM requirement. Then our building physics guys can add basically parameters to the model. Or we have like our engineers who basically add information to the Revit model, but without requiring the access to these tools and without needing a training to do so. It's just a simple user interface. You see in this video, you just have a 3D model from Speckle. You select a category. You then select the parameter, and this is basically out of our shared parameters API, where only the parameters are shown which are needed. So you see here, in this API, we only added this facade parameter. Then you just click on an object in a viewer or in a table. And then you see here basically the object selected. You can modify it. And then basically we use Speckle, the infrastructure of Speckle, to get it back into Revit. So this is basically an app connecting basically in between. And this makes it super easy. And this can be one of many ideas which we have in our heads. This data evaluation, we also will see a few talks, I believe, today. which basically also show this Power BI stuff. And then what is super interesting for us is what you guys are introducing tomorrow. So this Speckle Automate, that we have some kind of tool sets which are powerful as Grasshopper, but simple to use with just the click of the button. Things which are running in the background for guys to basically have faster insights. So this is something we did beginning of the year. We didn't have the chance to update it yet, but this is a column checker which checks if the column is running through without eccentricity or not. And in this case, we see here, for example, at the project Hello, we also have a colleague here from, this is the change tower. We have here a beam and then a column, and there's no column underneath it, so it basically creates a red sphere. So this kind of stuff helps us without needing to double check drawings, but basically have some kind of easy tool. So these are, of course, internal goals, but also externally, we see it like this. If we have guys like, for example, UN Studio with Cristobal or other architectural firms, other MEP firms, we see it as a way that we can find some kind of way how to work together. And also for Ljuba, as she's doing all of her competitions in the firm, that we are using for Frankfurt in Germany, that we have some kind of common way of working together with others and like basically have a close collaboration, not just on a verbal or design level, but also on a data-centric level. So not quite the end. We have a nice talk by our friends from Karama tomorrow. They are also introducing some nice stuff, which I've already seen a bit. So tune in there. And if you want to follow us on LinkedIn and Instagram, we have a really nice accounts here. And you can also, of course, contact us via email or just take a look at our webpage. Okay, so Q&A.
Thanks, we were even on time.
So
we have on it, everyone can see it. Do you convert all complex facade elements from Rhino to Revit? Have you handled Rhino blocks as nested families like bolts, anchors, screws, mullions? This is a good question because we are actually not handling the facade elements in Rhino at in this detail level. Yeah. It was in case really more detailed planning in Revit. So that's why for the one project that we showed, it was also actually a facade project, still the glass canopy, which we parameterized completely in Grasshopper for the workshop 3D model. We had also added the whole screws as axis with some information. But I'm not sure if this answers the question.
But also, like usually, what we see more and more is with Revit, we have a detailed geometry. In Rhino, we have abstraction. So it can be, of course, a building block. It can also be like a line. We only create the simplified elements in Rhino and then create a geometry in Revit, for example, for documentation in the end.
Yeah, or do a detail modeling on a certain detail, but just for one element to test the geometry and to find out where the geometry issues are.
Yeah. Okay, we hope that answered the question. Can you share your expertise in managing model synchronization with Speckle, particularly when dealing with extensive models and large number of elements? Do you employ a specific approach to dividing the model? So what we have followed up Speckle now since 2017. For example, this is a supernova, or 2018. This is a supernova we tried once with Speckle Works at the beginning. So since then, Speckle massively improved, and also we tested large automotive plants. So currently, we are in a situation that, for example, we just send parts to Speckle. What we saw today, we send, for example, panels. We send in higher level of detail and lower level, And with that selective approach, not just blowing over the whole thing, like which we usually do with IFC, if we send the whole stuff, but it's like not everyone needs the whole stuff. And then we still can combine this information. This is usually the best way how to approach it, and then it will not take hours. So it's a split up approach what we are doing.